Here's the wild part. You can build the answer in a single left to right pass with nothing but a stack. No sorting, no backtracking, just smart kicking out of letters you already added. Once you see the trick, you'll wonder why it ever felt hard. This exact pattern shows up in interviews at Google and Amazon under the name Remove Duplicate Letters. It's not just a puzzle either. Log processors and text pipelines use this same greedy stack trick to compress data while keeping order sane. Learn it once, spot it everywhere. You get a string, and you need to output a shorter string that has every distinct letter exactly once. Among all the orderings that are still valid subsequences, you want the alphabetically smallest one. So for CAB, the letters are B, C, A, and the smallest subsequence that includes all three in some valid order is ABC. A stack is like a pile of plates you only ever add or remove from the top. A hash map here just tells us the last index where each letter shows up, like a quick lookup table. And a set is just a fast yes or no checker for whether we've already placed a letter. So here's the trick. We walk the string and try to build our answer as a stack. Before we push a new letter, we look at the top of the stack. And if that top letter is bigger than our current letter and it shows up again later, we kick it out now and add it back when we see it again. In short, we always prefer a smaller letter now, but only if we're not losing a letter we can never get back. Look at this string B, C, A, B, C. By the time we reach index 2, our stack has B then C on it. But now it shows up, and since it is smaller than both, and B and C both appear again later, we pop them off and start clean with A. First, we build a map from each letter to the last index it appears at. This is what lets us safely ask later, does this letter come back again? Without this check, we might pop a letter and lose it forever. We start with an empty stack and an empty seed set. As we scan the string letter by letter, if we've already placed this letter, we just skip it, since we only ever want each letter once. This keeps the loop from ever adding duplicates. This while loop is the heart of the whole solution. We keep popping the top of the stack as long as it's alphabetically bigger than our current letter, and it still has a later appearance to fall back on. Notice what happens when the top letter has no later appearance. The loop just stops, because we can't afford to lose it. Once the popping is done, we push our current letter onto the stack and mark it seen. We repeat this for the whole string, and at the end the stack itself is our answer, so we just join it into a string. That's the entire algorithm, 4 small steps repeated in a loop. Before I show you, pause the video and trace it yourself. The string is C, B, A, C, D, C, B, C. What's the smallest subsequence with every distinct letter exactly once? Think about which letters get popped and why. The answer is ACT. Letters A and B make it in easily, but C gets bumped out early because a smaller letter follows and C comes back later. D sits alone since nothing smaller shows up after it, and B closes it out. I actually misread this one myself the first time and forgot to check last occurrence before popping, cost me a wrong answer submission. Honestly, the brute force idea is to generate candidate orderings and check which ones are valid subsequences of the original string, keeping the smallest. It's easy to explain in an interview and shows you understand the goal. But it blows up fast, so say it out loud first, then jump straight to the stack approach. The stack approach only ever touches each character a small constant number of times, so it scales beautifully. Brute force checking orderings grows way faster than the input, which is a deal breaker once strings get long. The stack solution runs in time proportional to the string length, since every letter gets pushed and popped at most once. Space is basically constant, since there are only 26 lowercase letters possible. Brute force blows up combinatorially, so outside of teaching the concept, there's really no reason to reach for it. If every letter is already unique, the while loop never fires, and we just build the stack straight through. If letters are already sorted, again nothing gets popped. But watch a string like acdb. Since every letter after the first never repeats, nothing pops even though it looks like it should, because last occurrence protects us every time. So to recap, we track where each letter last shows up, then walk the string building a stack. And we only ever pop a letter off the top if a smaller one is coming and the popped letter will reappear later. That one look ahead check is what makes the greedy choice safe. Keep shipping. See you tomorrow. Small channel, so a follow genuinely helps.